Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving headfirst into a fascinating piece by Piotr Migdal. Don't use cosine similarity carelessly. Get ready for some serious vector-based shenanigans.
Oh boy, here we go. Cosine similarity sounds delightfully mathematical. But carelessly? What's the big deal?
Exactly. It's like that Midas touch, but instead of gold, it's vectors. Migdal points out that while turning everything into vectors is incredibly useful, blindly using cosine similarity to compare those vectors is a recipe for disaster. It's all about the wrong kind of similarity.
Wrong kind? Like matching questions to questions instead of questions to answers? I see. So it's not about the meaning, but superficial stuff like typos?
Precisely. He uses the example of Python can make you rich versus Python can make you itch. Lexically similar, but semantically not so much. Cosine similarity might prioritize the lexical similarity, missing the actual meaning.
Whoa, that's a pretty big deal. So what's the problem with cosine similarity itself? Is it inherently flawed?
Not inherently flawed, but it's deceptively simple. It's a quick fix, like duct tape. It works sometimes, but often masks deeper issues. It gives you a number between -1 and 1. But that number doesn't inherently represent probability or any meaningful metric. It's a correlation, not a causation.
Right. So it's the context that matters. Like, if you're training a model with cosine similarity, then it's fine. But if you're just using it as a post-processing step on embeddings from a model trained with a different objective function, you're basically gambling.
Exactly. Migdal emphasizes that unless your model was explicitly trained using cosine similarity, or a direct function of it, like a dot product of normalized vectors, you're working with a quantity you have no control over. It might work sometimes, but it's unreliable.
So what's the alternative? Besides not using cosine similarity, what should we do instead?
The million-dollar question. The best approach is to directly query an LLM. Ask it, is sentence A a plausible answer to sentence B? That leverages the LLM's power to understand the actual meaning and relationship between sentences. But that's computationally expensive.
Yeah, that's a bit overkill for large data sets. What about something more efficient?
Good point. We can still use embeddings, but instead of blindly using cosine similarity, we can train custom embeddings tailored to our specific task. We can fine-tune existing models or use transfer learning to create more focused embeddings. Think of it as decluttering, keeping only the features relevant to our specific definition of similarity.
So it's about tailoring the method to the problem, not just throwing cosine similarity at everything.
Precisely. Migdal also suggests pre-prompt engineering, crafting prompts that guide the embedding process to focus on specific aspects, or even rewriting the text to standardize it before embedding, removing superficial differences.
I see. It's all about being intentional and understanding the limitations of our tools. So no more careless cosine similarity.
Exactly. Remember, sometimes duct tape works, but for anything beyond a quick fix, we need more sophisticated tools. Thanks for joining us on Tech Bytes and News. Until next time, keep those vectors aligned.
Bye-bye.